Converting between Celsius and Fahrenheit. If you hear Celsius and Fahrenheit, what are these words measuring, or what does Celsius and Fahrenheit measure? Celsius and Fahrenheit measure temperature. The difference between Celsius and Fahrenheit is Fahrenheit is what we use in the United States. It has a freezing point for water at 32 degrees Fahrenheit. And then Celsius is used in most other countries. It has a freezing point for water at 0 degrees Celsius. Now, something that I do want to point out is that 1 degree Fahrenheit is not equal to 1 degree Celsius. So if you said it was 33 degrees Fahrenheit, that does not equal 1 degree Celsius. They're not in it, the ratio of Fahrenheit to Celsius is not exactly 1 to 1. But the main difference between them is that the Fahrenheit has a freezing point of 32 degrees, and then Celsius has a freezing point at 0 degrees Celsius. When we're converting from Fahrenheit to Celsius, so if they give you degrees Fahrenheit and you want to change it to degrees Celsius, you're going to use the formula C for your degrees Celsius equals 5/9 parenthesis F minus 32, where F stands for the degrees Fahrenheit. Let's practice a couple of these. If I'm given 37 degrees Fahrenheit and I want to find what it's going to equal in degrees Celsius, I'm going to plug in 47 for F in the formula that I just showed you. So it's going to be Celsius equals 5/9 parenthesis 47 minus 32. Thinking back to the order of operations, we have to do what's inside of the parentheses first. So I have to do 47 minus 32 first, which is 15. Now I'm trying to multiply a fraction times a whole number. Remember, we multiply fractions straight across, and I can write any whole number over 1 to be equivalent to itself. So I'm going to multiply 5/9 times 15 over 1. If you think back to when we were multiplying fractions, you can cross-cancel when we're multiplying. To cross-cancel in this case, we would be looking at 5 and 1 or 15 and 9. 5 and 1 cannot cross-cancel, so we're going to keep it 5 and 1. And then if you look at 15 and 9, they are both divisible by 3. So we're going to get rid of the 15, get rid of the 9. 15 divided by 3 is 5, so we're going to replace 15 with 5. And 9 divided by 3 is 3, so we're going to replace the 9 with a 3. Now we're ready to multiply straight across. On top I have 5 times 5, which is 25, and on the bottom I have 3 times 1, which is 3. Now this is an improper fraction. If you were listening to the weather, you would not hear the weatherman say, "It is going to be 25 over 3 degrees Celsius today." You're going to usually hear the temperature in a whole number, but for today, since we're in math class, we want to be a little bit more specific, so we're going to go to change it to be in decimal form. To do that, I have to divide 25 divided by 3, and when I divide 25 divided by 3, I get 8.3 repeating. So 47 degrees Fahrenheit is 8.3 degrees Celsius. These temperatures are equivalent. These temperatures, what this means is that if you were in a room that was 47 degrees Fahrenheit, it is the exact same temperature as a room that is 8.3 degrees Celsius. So it's an equivalent measure. It's just using different units, Fahrenheit and Celsius. The next example says 32 degrees Fahrenheit equals blank degrees Celsius. We're still using the same formula that I already showed you. This time we need to plug in 32 for F. So I have Celsius equals 5/9 times 32 minus 32. Well, when you do what's inside of the parentheses, 32 minus 32 is 0. So Celsius equals 5/9 times 0. And anything times 0 is 0. So 32 degrees Fahrenheit equals 0 degrees Celsius. This makes sense considering the first thing that I said was that 32 degrees Fahrenheit is the freezing point for water and 0 degrees Celsius is the freezing point for water. So they have to be equivalent to each other or equal measures. The next example says, you are given that we have 17.2 degrees Fahrenheit, and we want to find what it would be in degrees Celsius. Plug in 17.2 for F in your formula. You have Celsius equals 5/9 parentheses 17.2 minus 32. When we subtract 17.2 minus 32, we're going to have a negative answer. It is negative 14.8. Just like what I have done before, I'm going to put my number over 1 so that I can multiply. So I have 5/9 times negative 14.8 over 1. I'm not going to mess with cross-canceling here. I'm going to look, and I can tell that 5 times negative 14.8 is negative, don't forget your negative sign, 74, over 9 times 1 is 9. Again, just like before, I don't want to be left with a improper fraction or a fraction to measure degrees, so I'm going to go ahead and multiply negative 74 divided by 9, and you get negative 8.2 repeating degrees Celsius. Now, if I am given degrees Celsius and I want to find degrees Fahrenheit, I'm going to use this formula. It says F for Fahrenheit equals 9/5 times C, which would be your degrees Celsius, plus 32. Notice in this case I don't have any parentheses. I am going to have to multiply 9/5 times the degrees Celsius first and then add 32 to that answer to find degrees Fahrenheit. The first example, I'm given that 15 degrees Celsius and I want to find the degrees Fahrenheit. I'm going to plug in 15 for C, so I have Fahrenheit equals 9/5 times 15 plus 32. Just like before, to multiply 9/5 times 15, I'm going to write 15 as 15/1. I need to go ahead and bring down the plus 32 also because I have not added 32 yet. Order of operations tells me that that is the last thing I'm going to do. When I'm multiplying, remember to check to see if you can cross-cancel. When I look to cross-cancel 9 and 1, the only thing that can go into both are 1 is 1, so it doesn't do anything to the numbers. But when I look at 5 and 15, those numbers are both divisible by 5, so I can cross them out. 15 divided by 5 is 3, and 5 divided by 5 is 1. Now when I multiply straight across, I have 9 times 3, which is 27, over 1 times 1 is 1. Well, when you look at 27 over 1, that is the same as the whole number 27. 27 divided by 1 is just 27. And when you add 27 plus 32, you find that 15 degrees Celsius equals 59 degrees Fahrenheit. The next example, we're given that we have 0 degrees Celsius and we want to find what it would equal if we were going to convert it to degrees Fahrenheit. I'm going to plug in 0 for C. When you go to multiply 9/5 times 0, we know that anything times 0 is 0, so I'm just have 0 plus 32. So if you have 0 degrees Celsius, it's going to be 32 degrees Fahrenheit. The last example, we have negative 5 degrees Celsius and we want to convert it to 2 degrees Fahrenheit. I'm going to plug in negative 5 for C. So I have 9/5 times negative 5 plus 32. I'm going to go ahead and write negative 5 as negative 5 over 1 so that I can look to cross cancel and go ahead and multiply. When you look at 9 and 1 to cross cancel, no number besides 1 can go into both of them. When you look at 5 and negative 5 though, really quickly, it's very important that you keep the negative 5. So be careful when you're cross-canceling and make sure that you still are going to have a negative number in place of the negative 5. Both 5 and negative 5 are divisible by 5, so I can cross them out. Negative 5 divided by 5 is negative 1. Notice it's still negative. And then 5 divided by 5 is 1. When you multiply these fractions, you have 9 times negative 1, which is negative 9, over 1 times 1, which is 1, plus 32. Well, negative 9 over 1 is the same as just negative 9 plus 32. You have different signs here. You have a negative plus a positive. So we need to go ahead and subtract the numbers. This answer is going to be positive because we keep the sign of 32 because it's larger and it is positive. 32 minus 9 is 23. So negative 5 degrees Celsius is equivalent to 23 degrees Fahrenheit.